You're still gonna help me, okay?
Okay.
So I got some blocks here. How many blocks? How much is that?
So, in the future, I should be ready. 42.
42. How do you know?
Because these are all tens, and if you count by 10, that's 4, and then if you add 10,
My first sentence is going to talk about my whole, which you told me is how much?
42.
So my first sentence in my division story, I'll say, there were 42. What should I write about? What would be a cool story? It can be fantasy. Cupcakes. That's a good one. Are you hungry? Because now you're trying to make me hungry. A little hungry? There were 42 cupcakes at lunch. So that'll be my first sentence, right? So my second sentence, I'm going to divide it up. This can either be, tell me how many groups of cupcakes I divided it into, or it can tell me how many cupcakes in each group. It can be one or the other. So which one do you think we should do? How many groups of cupcakes or how many cupcakes in each group?
I want to do the hard one, so I'm going to do how many are in each group.
Okay, so I'll say there were 42 cupcakes. I'm going to let you go ahead and group these into some equal groups. Let's make some equal groups. I'm going to put my 42 here because that's my whole. Ooh, so how many? Said, go ahead.
I have 5 in each group because I have 10s, and if I wanted to do 5s. So I did 5, 10, 15, and if you add 1,
check those 5s one more time.
5, 10, 15, wait, 20.
Okay.
And then
one more would make
1.
So I could.
20 here too.
So I could say there's 21 cupcakes in each group, right? So, okay. Hold on. I wonder. Could I do groups of 6? 6 cupcakes in each group? Like in your classroom, you have 6 kids at a team? I wonder if that would work for 42.
Maybe.
You want to try and see?
Yeah.
So let's do. We could totally do what you're saying. I'm just wondering, like, if I could, I would have to break up one of these 5s, right? See if we can make groups of 6. Break this one up to make that extra one.
Okay.
Well, these 2 have to be broken up to go with those 2 5s, right? Okay. Would this work too?
Yes.
Okay, so I could say there are 42 cupcakes at lunch. Each table had
6 in each.
6 cupcakes? Yeah, okay. So I could say there were 6 in each groups, but at lunch my groups are like tables, right?
Yeah.
So I'll say there were 6 cupcakes at each table, right? So if I told how many are in each group, then my question will be how many groups.
Yeah.
Okay, so my question would be how many tables have cupcakes? And look at this model that we built. How many tables of cupcakes could we make if we have groups of 6 cupcakes?
I would count by 5 and then.
You'll make your tables. Because our question says how many tables have cupcakes. How many tables do you see? 7. So let me borrow this marker. So there were 42 cupcakes at lunch. That's my total number of cupcakes. there were 6 cupcakes at each table. I told how many were in each group, right? So I did 42 and I split it up into groups of 6. And then my question was how many tables have cupcakes? So that would be how many groups I made, right?
Yeah.
I'm going to move my groups over. And we said that's 7 tables, right? Does that make sense?
Yeah.
Yeah? Okay, now I'm about to blow your mind because we're going to do it a little bit different. We're going to take the same number sentence, but instead of doing same exact one, we'll do 42 whole cupcakes still, but instead of dividing up telling how many are in each group, we're going to divide it up into 6 groups, and then we'll have 7 in each group. So all I'm doing is I'm flip-flopping these. Do you see that?
Yeah.
So in each groups, and now I have groups, and I don't need to write 7 because it's already there, in each group. So I wonder, is that going to change how our model looks?
Yes.
Okay, so can you bring those over here and make a model that would match this one? I would still have 42, right?
Yeah.
But now I need to make how many groups?
Of 7.
How many groups for this one? Because we had 7 groups for the last one. For this one, we still have 42, but we're doing it in how many groups?
6.
And so you'll know there will be 7 in each group. So were you thinking I can make groups of 7?
Yeah.
Okay, go ahead, do it. Let's see if it turns out to be 6 groups too. Just so you can like talk out loud while you're working.
So I am doing like I add 2 to here because there's already 5, and I add 2 plus 5 plus 2 equals 7.
So you're making groups of 7 is what you're doing. That's smart.
Might be.
All right, so now I have 42 and I've divided it up into 6 groups, and there's 7 in each group, right? You want to try to make words to match this one?
Yeah.
Okay, what would your first sentence be?
So,
And we can do, let's draw a line and we'll separate. We'll just write the second story below the line.
Okay.
So first sentence would be what?
There were 42 people.
Okay.
And that's how you spell each.
EACH. Don't even worry, I'm not stressing it.
Okay. Period.
Okay, read your sentence.
There were 42 people in each group.
Now look at your model. Is that true?
No. So
Okay.
Can I do 7?
You could, but we want to make it match that 42. So there's not 42 in each group, but there's 42 people in all, right?
Yeah.
So you can probably just put your period after the word people. There were 42 people. We could say where the people are. Where are the people? Where can they be?
They can be at school.
Okay, so instead of in each group, we can erase that and put there were 42 people at school. I'm starting with my total number of people. Excellent. Okay, sentence number 2. Put yourself in number 2. And a circle. Okay, sentence number 2 is going to be talking about my operation, which is division, and the 6. So and we're dividing this time, dividing into 6 groups. Last time we divided 6 in each group, but we flip-flopped them, right?
Yeah.
So now we're dividing into 6 groups. So what could that look like with people in school? When could you have
You can have
6 groups?
6 groups at math.
At math? Okay, so let's write a sentence about having 6 groups at math. They're split up into
6 groups.
6 equal groups, right? So 42 students. Oh, that sounds like my after-school tutoring. That does sound like my tutoring crew. So we can say, how do you want to say it?
At math, there were 6
Is this one 6 in each group? Or were there 7 in each group?
7 in each group, and there were 6 people.
There were 6 what?
Groups.
So, what could group 6? It could be 6 tutoring groups, right? Or 6 math groups?
Yeah, 6 math groups.
Okay, so you can say they were split. We got to say that it's split fairly or split evenly, right?
Yeah.
Because, I mean, I could have groups where it's not equal, but that wouldn't be division, right?
Yeah, so there were, what is it again?
We could say they were split into
Group. And then period.
Do we have how many groups?
6.
So we could say they were split into 6 equal groups. Do you want to do that?
Yeah.
Okay, split into 6.
They were split into.
Let's do they with a Y. It's okay. Split. SP. Perfect. They were split into 6 equal groups.
Yes.
6. You can do the equal sign. I don't care. Or you spell equal groups. You just need your R. Okay. Perfect. And S because it's more than one group. Period. Excellent. So far we have. There were. You read it to me.
There were 42 people at school.
Okay.
They were split into 6 equal groups.
Okay. So number 3 was going to be my question.
I know. Okay. So how many all together and how many all together?
Is this all together?
How many in each group?
There you go. How many people would be in each group? Okay, what would the answer be?
7.
7. So, does your model and your number sentence, do they match the question that you wrote?
Yes.
Isn't this tricky, this division though?
Mm-hmm.
Because I can take a whole and I can divide it into how many in each group, and my answer would tell me how many groups. Or I could take the same whole and I could divide it into a given number of groups, but then my answer would tell me how many in each group. Isn't that crazy? No wonder division's a little tricky. Do you feel better about it now?
Yeah.
Awesome. Thanks. Go ahead. You gonna say something else?
Yeah. And it's like confusing too because you don't know, like, if you do these and Miss Martin says you have to see which one is multiplication, which one is division. It's kind of hard to see.
Oh, do you want to turn this into a multiplication problem?
Yeah.
Okay. Oh, okay, come on this side. We have more table space. Okay, this is so exciting. All right, so if I wanted to write a multiplication problem with 42, 6, and 7, what could that multiplication problem look like? Dang, I'm looking like the Blair Witch Project with the way I'm holding my phone. Somebody needs to pay me money for my YouTube channel and get me a swivel. Okay, so if I had to use the numbers 42, 6, and 7 to make a multiplication problem,
You could.
which number?
I would use 7.
Okay, and you would do 7 times what?
Let's do 7 times 3.
But I got to use these numbers.
Oh, then 6.
Okay. Equals 42?
Yes.
How'd you know that 42 would go there?
Because if it was right there, it wouldn't be, kind of halfway wouldn't be multiplication. And if it was right there.
It would be, I could do 7 times 42, but would I get 6?
No.
No. So when I am dividing, I'm starting with the whole numbers. My biggest whole number would be up here, right?
Yeah.
And when I'm multiplying, my biggest whole number would be over here.
Yeah, and then if it was that 42 was right there, that wouldn't be multiplication.
I got a question. Could I do, is that fair?
Yes,
That
because
still means the same thing?
yes, because if you bring that 42, just X out that, and then equals 2.
So this equal sign, what does that mean?
That means the equal sign, hold on. X out that 2 and goes over here.
Do you know what the equal sign means?
It equals.
Equals? What does equals mean?
Equals means the number. Like the number.
Like the answer?
Yeah, the answer.
You want me to tell you what the equal sign really means?
Yeah.
Equal sign really means, the reason why this works is because the equal sign really means the same as. What does it mean?
The same as.
So let's imagine that this was balanced, like a balance scale. In order to be equal, it has to balance. So if I have 42 on this side, I need to have 42 on this side. Is 7 times 6 42?
Yes.
It is. So that would balance, right?
Mm-hmm.
But I could also do something like this. I could do 42 equals 40 plus 2. Isn't that true?
Yes.
Or I could do 20. I'm going to break up my 40 into 20 and 20 and 2. That's still 42, right?
Yes.
Equals 10 plus 30 plus 2. Isn't that also true?
Yes.
So the equal sign means the same as. That's why it doesn't matter what side it goes on, but that's a really common misconception. Kids think that the equal sign means the answer. In algebra, when you do algebra in middle school and high school, it's all about equality and the equal sign. Okay, so let's say we were going to write a problem about 7 times 6 is 42. Do you want to try, or do you want to watch me try? What do you want to do?
I want you to try first, and then I can try.
Then you want to try?
Yeah.
Why don't you build me out your model first for 7 times 6 is 42. Hey, doesn't it kind of look like what we already had?
Yeah.
It does. All right, well, I think you can do this.
Maybe.
Give it a try. I'll write. You tell me what I could write.
So you could write, since there's 7 times 6, and there's already like groups,
Mm-hmm.
you could do 7 groups.
Do I have 7 groups?
No, you have 6. So actually 6 groups.
I have 6 groups, but I do have 7 in each group, right?
Yeah.
So let's think about a unit we could write about. We wrote about people. We wrote about cupcakes. What could we write about for this one? Stuff that we could have 42 of.
42 toys.
Okay. So if I'm starting with 7, these are my 7 toys, right?
Yeah.
Could we be like at a toy store and these toys could be on shelves or in baskets?
Yeah.
Okay, so we got to start with 7 toys. There were 7 toys. How could 7 toys be set up in groups?
You could do 7 on one shelf, and then 7 on another shelf, and then 7 on another shelf.
Okay, but this is 14 on a shelf, right? We still want to keep our shelves with groups of 7,
Yeah.
right?
So groups of 7. So
So let me hold
here
on.
and a shelf right here.
So these are like, so we could do shelves like this.
Yeah.
There were 7 toys on what?
On each shelf.
Okay. On, I told you could do this because you're a genius. Just takes a little bit of practice. Okay. I need a sentence for this part. The 6 talks about what?
Talks about how many groups.
Okay, and we said our groups are shelves, right?
Yeah.
So can you give me a sentence about 6 shelves?
On each shelf there were 6.
There were 7 toys on each shelf. Now I just need to know.
There were 6.
And there's 6 shelves,
Yeah.
right? Whenever you get confused, look at the picture. It'll help you, okay? Okay, there were 6 shelves, right?
Mm-hmm.
Okay, so I could do a question or I could just write a statement. I could say there were 42 toys in all, but if I wanted to make it a question, how would that sound?
How many toys are all together?
Okay, or on all the shelves? Which one do you want to say?
All together.
Okay, makes sense. Because I'm trying to find the total, right?
Mm-hmm.
Sometimes some kids think all together means add. But this is a multiplication problem, and I have all together. That's pretty cool. That's why you can't trust keywords to solve problems. You got to look at those models and think about what's happening, huh? All right, so read me our problem and see if this matches.
There were 7 toys on each shelf. There were 6 shelves. How many toys altogether?
Does it match our model?
Yes.
Awesome. How do you feel?
Confident.
You feel confident?
Yeah.
Awesome. High five, girl. All right. You got to say, please subscribe.
Please subscribe.
And get post notifications.
Get post notifications.
To learn more about.
To learn about more math.
Oh, crazy math. You gotta,
crazy math.
To learn about Mrs. Steppa's hashtag crazy math. All right.
And then I want to shout out. Can I shout out?
Yeah, shout out, girl.
I want to shout out my sisters.
Your sisters?
Because they help me with math a lot. They're like, boom. They're like, if you get confused about this one, then here you go. If you get confused about this one, here you go.
Oh, what's their names?
Shiloh and Kehlani.
Oh, Shiloh and Kehlani. Shout out. Love y'all. All right, say bye.